A rhombus is a parallelogram with 4 congruent sides. So a rhombus, or plural, you'll see rhombi. Rhombi are defined by all 4 parallelogram properties. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But in a rhombus, not only are the opposite sides congruent, but the consecutive sides are congruent as well. So all 4 sides are congruent. The diagonals bisect each other because it's a parallelogram, but specifically the diagonals are perpendicular. Which means these 2 diagonals are going to intersect and form right angles. So I've just created 4 little right triangles because the diagonals of a rhombus are perpendicular, and the diagonals bisect the opposite angles. So this diagonal is going to bisect this angle and this angle. And notice, I'm using the same number of curvies and the same colors for these 2 halves up here and these 2 halves down here, because this whole angle is congruent to this whole angle because they're opposite angles of a parallelogram. So when I bisect them, the halves are congruent as well. But notice, I'm switching colors, and now I'm going to start using 2 curvies for these halves. So these opposite angles, these blue ones, are congruent, so when I bisect them, their halves are congruent as well. But notice these orange angles and blue angles are not congruent. So the diagonals are going to bisect the opposite angles in a rhombus. So in this example, if the diagonals for figure ABCD meet at point F, so here I'm going to draw my diagonals in, they're going to intersect at point F. And we know the measure of angle CBF. So CBF is this angle up here. It's 22 degrees. We want to find the measure of angle DCF. So we know that the diagonals of a rhombus are going to be perpendicular. So I know that this is going to be a right angle. This is a 90-degree angle right here. So now I have this cute little right triangle right here. And so all of the angles in the right triangle add to, or into any triangle, add up to 180. So I'm going to do 180 minus 90 minus 22. And I'm going to get that this angle is 68 degrees. But we are looking for the measure of angle DCF. Well, my diagonal of this rhombus is going to bisect this angle. So this angle is 68 degrees. So this angle right here will also be 68 degrees. And the measure of angle DCF is 68 degrees. In this example, we want to solve for the measure of angle WST. So first thing, if this is a rhombus, which we should have told you was a rhombus, so let's add that in. STVR is a rhombus. Oopsies. We know that the diagonals of a rhombus are perpendicular, so that would make this a right angle because the diagonals are perpendicular, so the measure of that angle is 90 degrees. So I can set 2y plus 10 equal to 90 degrees because the diagonals of a rhombus are perpendicular. So 2y equals 80, divided by 2, and y is 40. So now I can go take y is 40 and I can go plug it back in. Wherever I see y, I can go substitute it. So angle TSW is going to be 40 plus 2, which is 42 degrees. And that's what I'm looking for. Angle WST is going to be 42 degrees.